soft copy of the book by Madala, in that case, you can also share it in your Google Classroom. Okay, so at a broad level, econometrics is the science and art of using economic theory and statistical techniques to analyze economic data. Prutush tried to mention all these things. So this is the core issue of econometrics. We will handle economic theory and statistical techniques together to analyze economic data. And you are finding that econometric methods are used in many branches of economics, including finance, labor economics, macroeconomics, microeconomics, marketing, economic policy. Everywhere you need to analyze the data. Only theory will not work. You have to make a mix and match with your theoretical knowledge along with what you are getting in reality. Okay, so a few examples I started to give, how econometrics or knowledge of econometrics help us to analyze the data, or what is new in econometrics. Okay, what we didn't get in statistics, what we didn't get in theory, what new things it will bring to us. Okay, so you can consider this first example. Does reducing class size improve elementary school education? As I mentioned, the general idea is smaller the size of the class, better the result, better the performance of the students. However, if you collect a number of data, okay, you are finding that 420 California school districts in 1999 were considered by Stock and Watson, and they are finding that wealthier residents are sending their kids to this kind of schools, and they can support some opportunities, they can give support to some opportunities apart from or outside the classroom too. And combining several aspects, their result may be very good. Okay. So econometrics help us to control the other factors. That is, we can consider, when you collect the data from reality, you will find that there are people with different tastes and preferences. Okay. Now, we can find out what will be the relation between quantity demanded and price for particular groups. If a group of individuals belong to a typical type of cultural pattern, what will be the demand curve? If they belong to another type of cultural trait, what will be the type of demand? Okay, so for different tastes and preferences, or for different culture, what will be the demand? Okay, it is not as a whole relationship. There is this kind of relationship between price and quantity demanded. Okay, for different groups, it may be different. The demand curve may be negatively sloped. However, the elasticity may be different. Okay. And if I control different aspects, then what will be the shape of the demand curve for this particular group? That is, if there is no difference in culture, if there is no difference in parental education, if there is no difference in income, then what will be exactly the relationship between price and quantity? Okay, in case of theory, we will be not able to do the things in that way. However, econometrics will give us some tools, some techniques by which we will be able to control other factors. Controlling other factors, what will be the relation between the concerned two variables that we can derive. Is it understandable, or what I want to tell you, is it understandable? Are you understanding the matter? That econometrics help us to control for other factors?
Yes, sir.
Okay, the second problem is, in reality, there are different types of biases. When you consider different types of samples, the sample may be representative, then also there may be a kind of bias. we are considering a particular question. Is there racial discrimination in the market for home loans? This is the question. In general, you will find that for most of the countries, people are telling that yes, there is. There is racial discrimination. You know, if you look at the home loan markets, or if you look at any financial markets, you will find this kind of discrimination. However, it may be the result of the fact that a group of people could not fill up the form perfectly. Actually, when you are getting some loan or you are in the finance market, you are analyzing the final result. However, how many people actually applied, and what, after cleaning the database, what are the forms which are perfect, that information you are not getting. So it may happen that if people come from the poorer section of the society, if people come with lesser education, there is this kind of problem that they could not fill up the form perfectly. And for that matter, they are not getting the home loans. So actually, there is no discrimination in the home loan giving pattern. Rather, there is discrimination in education. There is discrimination in wealth index or wealth holding. And for that matter, you are getting this kind of result in the home loan market or the financial market. Okay. So actually there is a bias in the sample, and the reason of bias is not that market, reason of bias is somewhere else. And for that matter, here you are getting a biased result. Just a minute. Since election is taking place following several courses, the entire environment is becoming very noisy. Okay, so I'm talking about bias. Okay, so I think you have understood the actual reason of not getting home loans is not the discrimination among the people. The reason is, yes, there is discrimination, but the discrimination is at somewhere else, not here. So policy should be something else, not the policy should not be, you have to stop discrimination in the home loan market or in the financial market. The policy should be, you have to improve the educational context of the people, or policy will be, there should be some kind of improvement at the poverty level. Okay, so these are the things. Econometrics help us to identify the exact reason, and therefore, it help us to find out the proper policy direction. Third, how much do cigarette taxes reduce smoking? Okay, so you go through these example. Already I mentioned about the relationship between growth and happiness. Whether happiness determines growth or growth determines happiness, we are not understanding. Sometimes in the commodity market this happens. Whether the quantity determines price or price determines quantity, we do not understand. There is one-to-one relationship between the two, and sometimes we actually do not understand which determines what. Okay. Growth and happiness, this is the classic example of this kind of endogeneity issue, or we may call this issue the simultaneous causality issue. So econometrics gives us several techniques by which we can control this simultaneous causality, or we can resolve the problem of simultaneous causality. Okay. The fourth important aspect of econometrics is forecasting, prediction, forecasting, etc. What will sales be next year at a firm that is considering investing in new equipment, or will the stock market go up next month, and if it does, by how much? Will city tax receipts next year cover planned expenditure on city services? Will microeconomics exam next week focus on externalities or monopolies? Okay, so all these kind of questions, what will be there? On the basis of past experience, what can be the future? Okay, so econometrics give us several tools and techniques so that our prediction or forecasting for the future will be good or will be better. So far, I discussed about several aspects for which actually we learn the econometric tools and techniques. Next, I'd like to tell you something or some relation between cause and effect. এত হই হই হচ্ছে না বাইরে, বাবা আমি কনসেন্ট্রেটই করতে পারছি না। Cause and effect relations. কালকে তোমাদের বোধহয় অনেকেরই ভোট আছে নাকি? তোমাদের অনেকের এরিয়াতে ইলেকশন আছে কালকে? ওকে, হ্যাঁ, yes, it is on Saturday. কাল কেন বলছি? It's on Saturday, yes.
Yes, ma'am.
Yes. And for that matter, I could not imagine all these things will take place during the class hour only. So it's I'll talk about something about cause and effect relationship. In case of econometrics, we will start with the functional form. Y is equal to fx. Okay. Then we can, define this f. Generally, we start with linearity. So we consider this f as a linear function so that we can write the function as in this way. Y is equal to alpha plus beta x. A linear functional relationship between y and x. You are very, very familiar with this kind of relationship: demand curve, supply curve, investment, savings, consumption, So you are very familiar with this kind of relationship. The new thing here we will bring, this is the exact relationship. Between y and x. Exact relationship between y and x. Okay, generally in economic theory we consider this kind of relationship. However, when you will consider the database, you will find that the relationship is not exact, rather random, because there is some possibility of occurring error in the analysis. Theory is telling that the graph will be like this. However, when you are considering the reality, you are not getting this kind of graph, rather you are getting this kind of scatters, observations. These are all observations. Now, if you fit a line through observations, you will get this kind of solid line. However, all the points of the observations are not lying on this particular line. there is a gap between the observation and the line, So if you consider this point, there is this kind of gap. If you consider this point, there is this kind of gap. So there is a distance between the observed and exact. Okay. This difference between observed and exact is called the random error. This is the random error in the analysis. Now, in general, it is assumed that this is cause and this is effect. So econometrics basically gives us a relationship which is actually the relationship between cause and effect. Okay. Now there is a huge literature on this, whether really econometrics gives us the causal relation or not. It gives some relation, however, it is not a causal relation, or really it is a causal relation, etc. Okay. Now, if you just throw anything in a pond, it will sink. Okay, so here really there is cause and effect kind of thing. If you touch something hot, you will have some kind of sensation. So really there is some cause and effect kind of thing. Okay. In reality, when you are collecting data and trying to frame the model, always it is not the cause and effect kind of thing. If it is production of potato depending on fertilizer, yes, it is cause and effect kind of relationship. However, when you are considering growth and happiness kind of situation, you do not know which one is cause and which one is effect. Okay. So, if there is nothing endogenous in the system, in that case, you can say econometric relations gives us cause and effect kind of relationship. However, if all x's are not external, if there is some kind of endogeneity between the right hand side and left hand side variables, in that case, we cannot call it cause and effect relationship. Okay. So in the beginning, all the literature thought that econometrics gives us cause and effect relationship. However, as continuously the experiment went on, people started to realize if all x variables we are considering in the right hand side, these are really external to the system or exogenous to the system, in that case, it can be considered as cause and effect relationship. However, if there is endogeneity issue is there, which part is cause and which part is effect, that we will not understand. So we cannot say econometrics is always giving us cause and effect kind of relationship. So coming back to our slide, causality means that a specific action, as I mentioned, applying fertilizers, leads to a specific measurable consequences, more potatoes. If this kind of relation is there, for example, touching a hot stove causes you to get burned, drinking water causes you to be less thirsty, putting air in your tires causes them to inflate. Okay. So if there is this kind of relationship, all these are causal relation. However, if there is endogeneity, the relationship will be not causal in nature. Okay, so go through this part. I'm not considering all these things here. You will find, finally, if actually you will finally find that if all variables are exogenous to the system, in that case, you will get this kind of causal association. Otherwise, if there is endogenous variable in the system, in that case, this kind of uh, context cannot be considered as a causal relation. So you go through the things. I hope you will understand. If there is any confusion, I'll discuss all these things in the next class. Okay. Now, when we are talking about association, causation, etc., the two very important concepts are correlation and regression. These are the two very important concepts in context of association, etc. Correlation and regression. Correlation is a symmetric analysis. I think you have idea about the correlation metrics, idea of correlation, association between two variables. Do you have idea about that? Do you have idea about the correlations among the variables? Anyone? Aratri? Who are there? The voice is not clear.
Can you hear me?
ম্যাম আমরা এটা এসিসি তে করেছি, আমরা এটা এসিসি তে কোরিলেশনটা করেছি, কোরিলেশন ফাংশনটা দিয়ে ডাটা অ্যানালিসিসে।
আচ্ছা,
পুরো ডেটা অ্যানালিসিসটাই করেছি ম্যাম, মানে স্ট্যাটে করি, স্ট্যাটে মাল্টিভিরিয়েট হয়নি।
Okay. So you have some idea that how you can measure the Pearson's product moment correlation among the variables, and correlation measures, I think you have idea that correlation measures the degree of association among the variables. If it moves towards the one.
হ্যাঁ ম্যাম, এটা আমরা স্ট্যাট জি তে করেছি।
হ্যাঁ, বুঝতে পেরেছি, তোমরা এসিসি তে করেছো, যেখানে তোমরা ডেটা লার্নিংটা করেছো সেখানে তোমরা করেছো। Yes, it is fine, কিন্তু if you understand the things, then it's fine. Where you did this thing, that's not important. Okay. So correlation measures the degree of association between the variables as the value moves towards +1 or -1. That means the two variables are perfectly related to each other, positively or negatively. If the correlation value is greater than 0.5, plus minus 0.5, in that case, the correlation is quite good. And if it is 0.2, 0.3, in that case, correlation is not that good among the variables. So correlation helps us to measure the degree of association among different variables. However, it does not differentiate between which variable is dependent variable and which variable is independent variable. It simply measures the degree of association. There is another measure which we call the regression analysis. Regression analysis talks about the degree of association or tries to establish the association, how the variables x and y are associated to each other. The specialty of regression analysis is here one variable will be considered as dependent variable, and there will be one or several variables which will be considered as the set of independent variables. Okay, so we categorize the variables here. In case of correlation, we consider degree of association. However, we do not make any categorization among the variables. Whereas when we go for regression analysis, we categorize among the variables. One variable will be considered as the dependent variable, and another variable or another group of variables, set of variables, will be considered as independent variables. In our earlier context, in the particular equation I have written, x is the independent variable, y is the dependent variable. So there is a categorization among the variables. However, if it is a correlation between y and x, there will be no categorization among the variables. And what I also mentioned, the equation could be So there can be a number of independent variables. If y is demand, x1 may be price of the commodity, x2 may be price of the substitutes, x3 may be income of the consumer, and you can increase the number of variables here. Okay. So in case of regression, we will have one dependent variable or study variable. This is called the and all these x1, x2, x3, these are the these are also called the control variables. As we move further, we will understand, these are not only considered as independent variables, these are all controlling factors, income, price of substitute. This can be considered as the controlling factor, controlling for price of substitutes, controlling for income of the individuals. We can find out the relationship between y and x1, or controlling for x1 and x3, we can find out the relationship between y and x2, and so on. Okay, so this series of variables, these are independent variables, control variables, or these are also called explanatory variables. This can be considered as explained variable, and okay, and in the language of regression, these are also called regressors. So different names, however, the things are same. Okay, all x variables can be considered as regressors, independent variables, control variables, explanatory variables, and the variable which will be there in the left hand side, dependent variable, study variable, regression, explained variable. So it has these names. So, both the correlation and regression gives us, some association among the variables. However, remember, correlation never will identify which is a dependent variable, which is the independent variable, etc. Regression will do that. Now, before starting to discuss about regression analysis or the basic tools of econometrics,
Ma'am,
let's understand. Yes.
বলছিলাম যে ওই আগের পেজটাতে কোনটা রিগ্রেশন আর কোনটা রিগ্রেসর ওইটা ঠিক বুঝতে পারলাম না। ওই যে যেটা একটা ইকুয়েশন দিয়ে দেখাচ্ছে।
কি বলছো?
হ্যাঁ, এখানেতে কোনটা রিগ্রেশন বললেন আর কোনটা রিগ্রেসর বললেন?
This equation is called a regression equation. Y is equal to alpha plus beta x1 plus gamma x2 plus delta x3 plus u. This is called a regression equation. This is not a correlation matrix, rather it is a regression. Okay, this.
আচ্ছা, আর রিগ্রেসর বলে কিছু বললেন তো?
This is a regression. Okay, first of all, this is the thing. Then the right hand side variables are called regressors, and the left hand side variable is called regression. SANT. Okay.
রিগ্রেশন SAN.
Yeah. Regressant. Y is called dependent variable, study variables, explained variable, regression. X variables are called independent, control, explanatory, regressors. Okay. Got it, Darpur?
হ্যাঁ ম্যাম।
Now, before moving to the tools and techniques of econometrics, let's have some idea about the different types of database. Because we are talking about the data, we have to handle the data. Okay. So there are three possibilities. We are considering only one cross section. So we have cross section data. For example, we are considering Indian database regarding, COVID for the year 2020. So it's a cross section data. We are considering a particular spot at a particular time point. So it's a cross section. Next, time series data. Okay. We can consider production for last 15 years. We are considering the production data of some industry for last 15 years, or overall GDP of India for last 25 years. What is the trend in GDP for the last 25 years? Okay. So if we consider this kind of thing, many time points, in that case, it is called the time series data. We are considering it about India for a country, however, for a long period. So it's a time series data. Now we can have a mixed and match. That is, we can consider GDP of 10 countries, okay, 10 developing countries for last 25 years. Okay, so if this is the case, we are considering data of 10 countries for last 25 time points or 25 years. In that case, we call it a panel data. It is a combination of cross sections as well as time points. Several cross sections we are considering, 10 countries we are considering, and we are considering all 10 countries for last 25 years. So if there are number of cross sections, number of time points, we call the data a panel data. In this semester, we will concentrate only on cross section data because we are starting the thing, so we will be not able to handle time series data, panel data, everything in this semester. In this semester, we have cross section data following the UGC CBCS structure. And in the advanced course or the optional course, we have some idea about how to handle the basic time series data, how to handle the basic panel data, etc. So now, henceforth, we will concentrate only on cross-section analysis. That is, we are considering, suppose, a country or a region or a state or a district, whatever. And for that particular district or state or country, we are considering one particular time point. Okay, so it can be today, it can be this month, it can be this year. Okay, so a single cross section and a single time point we will consider. Okay, and we will start first talking about regression analysis, and in some context we will bring several issues related to correlation. Okay, so let's start the regression analysis and let's do it for the cross section. Now we will start with a very simple model. That is, we will have one dependent variable and one independent variable. That is, y is a function of x. We will start with this. Y is a function of x and this f is linear because linearity is a good starting point. If you get non-linear models under most of the circumstances, you can make it log linear. If you take logarithmic transformation, that polynomial will come to a linear one. Okay, so linearity is a good starting point. And in our theoretical foundation courses in micro and macroeconomics, generally we consider the linear model. Okay, so to gel with your basic knowledge of economics along with how to handle these models using the database, it will be good to start with a linear structure. Okay, So we will consider regression analysis number 1. We will consider cross section for this regression analysis number 2. And number 3, we will first start with linear framework. Okay, that is the function we will consider that will be linear. Now, econometric analysis has 3 parts. Better to say, we are concentrating on regression. It has 3 parts: assumptions, estimation, and later, as I mentioned, we will try to cover some issues related to prediction analysis. Okay. However, these 3 are major parts in our analysis. And as I mentioned, we will start with a linear structure. And we will start with a single explanatory variable, which we call a simple model, 2-variable model, a simple model. We will start with a simple model, and later we will extend this model incorporating a number of explanatory variables in it. So let's first start with the assumptions of the model. Okay, before going to the assumptions, just a few examples that may help you to understand, it's not very special. A simple model cannot give us anything. So this kind of research questions we will like to handle. State implements tough new penalties on drunk drivers. The question is, what is the effect on highway fatalities? Okay, so effect of tax or penalties on highway fatalities. This kind of question. A school committee cuts the size of its elementary school classes. What is the effect on its students' standardized test scores? You successfully complete 1 more year of college classes. What is the effect on your future earnings? Your per capita income increases by 1 unit. What will be the effect on your consumption pattern? Okay, so these kind of questions we are going to handle. What is the relation between Y and X? Okay, as I mentioned, in this module, we are going to introduce the linear regression model relating one variable X to another variable Y. This model postulates a linear relationship between X and Y. The slope of the line relating to X and Y is the effect of a 1 unit change in X on Y. Just as the mean of Y is an unknown characteristic of the population distribution of Y, the slope of the line relating to X and Y is an unknown characteristic of the population joint distribution X and Y. So what I am telling, if I go back to this equation, we have 2 parameters here, alpha and beta, 2 parameters here. Alpha is the intercept of the model, beta is the gradient. What beta is indicating? Dy dx. For 1 unit change in X, how much Y will change? For 1 unit change in tax rate or penalty rate, what will be the effect on street accident, this kind of thing, dy/dx kind of thing. And what else I mentioned? Alpha and beta are unknown characteristics. These are the population parameters. On the basis of the observations on y and x, that is on the basis of the sample observations, we are going to estimate the population parameters here. So remember that alpha and beta are unknown population characteristics. On the basis of x and y, we will like to estimate these unknown population characteristics. On the basis of the observations, we will like to estimate these unknown population characteristics and establish a relationship between y and x. Okay, so actually from the sample, we will like to move towards population. From the sample observation, using the sample observations, using the estimation technique, we will calculate alpha and beta, and we will get the estimated estimated relationship between y and x. Any question?
No, ma'am.
Any question? What's the question? Is there any question?
No question, no question. No, 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 ma'am.
Okay, so this can be the form of the equation. You know, consumption is a function of per capita income. So this is an example. You will get it. Okay, and these are the observed relationship. As I mentioned, x and we are getting basically the observed relationship between y and x, and from this observed relationship, we are trying to find out the curve, the fit, or the estimated relationship. Okay, so one by one, I'll come to all of this. You know, already I mentioned about all these things. You know, that is, we are getting the observed values, and then there is a fitted line. Actually, from the theory, we get the idea about the exact relation or what will be the nature of the fit. However, when we are going to the reality, we are getting the observations are moving around the fit. It is not that observations are lying on the fit. So there is a probability that there will be some random error in the structure. So actually the regression analysis, or actually when we are trying to find out the unknown parameters, basically we will like to reduce these gaps, you know. We will like to minimize these distances. As we can minimize these distances, actually all the observations are truly indicating this particular relationship. If we can minimize these error probabilities, in that case, this line will appear as the real relation for the population too. On the basis of the sample, we will try to estimate it. However, really, if we can reduce or if we can minimize the error components, in that case, this line will indicate the relationship for the entire population too. So this is the idea. Let me start talking about assumptions first, then we will come back to all of these issues, because the things are not that simple, you know. So one by one, we need to construct all these things. So it will be better first if we move towards assumptions of the model, and then after completing assumptions, we try to understand what will be the real presentation of the regression equation, how we can really minimize the random error, and how we can really estimate the parameters. Then the things will become clear. So we will come back to these slides later when we will start discussing about estimation technique. Okay, so let me first move towards assumptions. This will help us to frame some idea, and then we will come back to the analysis. Now, before starting assumption part, I have to reiterate the fact that there will be a random error component in our analysis. There will be a random error component in our analysis. So when we are going to the assumption part, okay, mostly the assumptions will concentrate on this random error component. So what basically we are doing here, again I am repeating, this relationship we are getting from our knowledge of theory. However, when really we are collecting data, we are getting this kind of observations. Okay, and or this gap or this gap. These are called so once again, this is the exact functional relationship which we get from theory. However, this is the observed which we are getting from empirical investigation, and then finally actually we will find this on the basis of our observed relationship. We will find out this model. This is the estimated relationship between okay. Now, if you subtract the first model from the second one, we consider these two and subtract the first from the second one, the only difference is U. This U is the random error component. Okay, since this is new here, this is new here, y is equal to alpha plus beta x we learn from economic theory. U is new here, so whatever assumptions etc. here we will do, that will concentrate on this error term. Assumptions will center around the random error term U. Assumptions will center around the random error term U. Okay, and then after completing assumptions, we will learn how to minimize error, and then how to estimate alpha hat and beta hat, and how to reach at y hat estimated relationship.
ম্যাম ছবিতে ওই ডিস্টেন্সটা র্যান্ডম এরর?
Yeah, all these distances from the scatter to the exact line, so this is the exact relationship. If you look at this equation, this is y is equal to alpha plus beta x. Okay, and these vertical distances, these are called the random errors, the vertical distance of the scatter from the feet. Okay, so this kind of regression is called regression of y on x, and here we consider the vertical distance between the scatter and the plot as the random error. Okay, now there may be reverse regression as well. Later we will talk about these two. Okay, later we will talk about these two. This is the reverse regression. This is the regression of, and in this case we will consider the horizontal distances as errors. So suppose these are the observations or scatters. So we have to consider these distances. So if I consider the reverse regression, we have to consider these as the random errors. Okay, so these are also the horizontal distances. These are also random errors. Okay, got it? So with this background, we are going to do the regression analysis. It is the extended framework of a theoretical model. Theoretical model is providing us exact functional relationship, whereas when we will collect the data, it's not that all the observations will lie on the line. It will happen that observations are moving around the line, so there will be a scattered diagram, and along the scattered diagram we can have a feet, considering the mean values, we can have this kind of feats. So later I'll talk about mean values, etc. So this kind of fit we can get. Okay, so let's discuss. Yeah,
আমি প্রথম ডায়াগ্রামে লেফট সাইডে ম্যাম ওই যে লাইনটা এঁকেছেন ওটা কি রিগ্রেশন লাইন না রিলেশনটা এক্সাক্ট রিলেশন?
exact relation. Okay, later we will consider this line as when we will understand the estimation part. Actually, this will be on the basis of the data. We cannot estimate the exact kind of thing, minimizing error. Actually, this line in reality will give us this kind of thing. However, to begin with, we are telling that this red line is coming from the theory. We have some knowledge that demand will be negatively sloped. And then we are collecting data. Yes, we are getting some negative trend when we are looking at the scatter. And then we are trying to estimate the red line. So actually it will be y hat equal to alpha hat plus beta hat x, because y is equal to alpha plus beta x is a theoretical framework. It is not observed. Okay, this is unobserved kind of thing. It's simply the theoretical model, isn't it? So on the basis of the data, if I can find out something, if I can plot something, that will be estimated one. Okay, so let's first start with the assumptions, then estimation, and then we can understand actually the red or the green lines are the estimated lines. The actual line is the theoretical line. It cannot be observed. It's just the idea. It's the idea about the relationship between y and x. It is not observed, isn't it, Abhishek?
Yes, ma'am.
Any other question? Do anyone have any other question? Okay, so we are coming to the assumptions part. So the first assumption regarding error term will be errors are unbiased. Errors are unbiased. First assumption. Expectation of UI is equal to 0. Okay, expectation of uy is equal to 0. Though there is an error, the mean error, expectation of ui, the mean value of the error, expected value of the error, that is equal to 0. The expected value of the error is equal to 0. Okay, now suppose and then we are taking the expectation. Expectation of alpha is equal to alpha. Now, if you consider beta like this, okay, if x is non-stochastic, in that case, expectation of xi will be x bar under most of the circumstances. So it will also give us a fixed value. Now, if expectation at this moment, we are not interested about this part. Our focus will be totally on this part, expectation of u. Suppose expectation of u, suppose it is equal to any arbitrary constant k. In that case, we can write the frame in this way. So we can adjust the value with the intercept term. So in ex ante situation, okay, with some fixed error, we will not start. It is rationality that to begin with, we will start with a model when expected error is equal to 0. Because from the very beginning, expected error will be this. So this will be adjusted with the intercept term. This is number one. Number two, when we are considering any regression equation, you know. Any exact relationship, y is equal to alpha plus beta x. If the errors are random, it will be evenly distributed to the positive and negative direction of the fit. If the errors are really random, you will have even distribution of these random errors against the fit. Okay, so number of, say, positive errors will be exactly equal to number of negative errors. Okay, so if you consider the expected values, that is the mean error, in that case, the errors will cancel to each other and the expected value will be equal to 0. So if you consider expectation of ui is not equal to 0, in that case, actually your scatter is non-random. It's not a random situation. If it is random, then you are telling the situation or telling the system or telling your model that number of positive discrepancies will be exactly equal to number of negative discrepancies, and for that matter, the expected value of the error term that should be equal to 0. I'm repeating, number of positive discrepancies will be exactly equal to number of negative discrepancies, and for that matter, finally, the mean or the expected value of the error term should be equal to 0, should be equal to 0. Okay. So expectation of ui is equal to 0 is a very natural assumption. Okay. So it is not the assumption like, you know, you are forcing something to the model. It is not very, very stringent kind of assumption. It's a natural assumption. It is the consistency requirement. Okay. So it is a natural assumption. Or this is, you can say that, consistency requirement. Okay, everybody, this is a consistency requirement. It's not at all a stringent assumption. Okay. The classical linear regression model, the model we are going to frame, that is a classical linear regression model, is based on stochastic specification of UI as follows. As I mentioned, all the assumptions will center around UI. And why it is classical linear regression model, you are understanding, because I mentioned we are going to discuss the regression model. This kind of relationship between y and x is called the regression model. Okay, so you are understanding that we are discussing about the regression model. Now the assumptions or the set of assumptions I'll mention, you know, that will make the model a classical one. If we follow all these assumptions, you know, in that case, the model will appear as a classical model. And as I mentioned you, linearity is a good starting point, because under many circumstances, if the model is non-linear, we can make it log linear. Taking the logarithmic transformation, we can make the model a linear one. Okay, so linearity is a good starting point. So the model we are going to discuss is a classical linear regression model, CLRM. Okay. And the first assumption is expectation of UI is equal to 0. And this is a consistency requirement. And I hope you understood why it is a consistency requirement. For your better understanding, you have the references with you, Stock and Watson. You can start with Stock and Watson. Later, under some certain context, we will also discuss some issues from Johnston and Donato, Ulrich, etc. So you can start with Stock and Watson. And you can go through all these things, and you go through the lecture, you will understand, I hope, why it is a consistency requirement. Okay. The second assumption is uniform variance assumption. Uniform variance assumption. Actually, we got this assumption or this term when we discussed our inference. In a typical context of hypothesis testing, we got this assumption, homogeneous variance assumption, or homogeneous variance is called homoscedasticity, heterogeneous variance is called heteroscedasticity. This term we got earlier in our earlier semester. Okay, so what about the second assumption? This is the assumption regarding variance of UI. Now, while we discuss properties of any variable, be it random, be it non-random, first we'll discuss about central tendency. Next, we discuss about dispersion. So first assumption we considered that was regarding expectation of UI. That is some assumption regarding the central tendency of the random variable UI. Naturally, when we will bring the second assumption, it will be based on idea of dispersion. Variance is a good measure of dispersion. Okay. So the second property of the error is based on variance of UI. Actually, it is trying to tell us something regarding the dispersion of the random error term UI in our regression model. Now we are considering the fact that across groups, across different cross sections or across different groups, the variance remains unchanged. The variance remains unchanged. In your eye, there may be people who remains in the topmost asset holding category. Again, you may have information or you may have data for the person who is staying below the poverty line. Okay. Homogeneous variance means, if you consider a model, regarding income and consumption, homogeneous variance means the MPC, marginal propensity to consume, or the variability of marginal propensity to consume, that does not change between different income classes. The variability of MPC remains unchanged among different income classes. From your macroeconomics, using the multiplier theory or all the concepts of MPC, for the poorer section of the society, MPC will be very high, whereas for the richer section of the society, MPC will be very low. Only a very, very small part of the income will be consumed for the people having a very high income level. Okay. However, to begin with, in our regression analysis, we are not differentiating between these groups. We are assuming that variability of consumption and income remains unchanged across different income classes. Okay. So homoscedasticity means this kind of thing. Variance of UI, we consider a constant given by sigma u square. Okay, for all I is equal to 1 to n. The reverse should be sigma I square. Okay, it will vary from individual to individual. So for the first individual, it will be sigma 1 square. For the second individual, sigma 2 square. Or if you consider the household, for For the first household, it will be sigma 1 square. For the second household, it will be sigma 2 square, and so on. That is the notion of heteroscedasticity. However, in a classical model, we will consider this variance to remain constant across different individuals we are considering in our database. Okay. Now, variance of UI is basically expectation of by the first assumption. Expectation of UI is equal to 0 by the first assumption. So variance of UI in our model is given by expectation of UI square. And this expectation of UI square by the assumption of homoscedasticity, we are considering to be a constant for all I is equal to 1 to n. Any question? Are you understanding the assumption of homoscedasticity? Okay, so this is this assumption, uniform variance. Variances are uniform for all I. So next day I'll talk about, the assumption regarding covariance. Today you just check what homoscedasticity means. This is the blue line is the fit, and there are scatters around it. We have considered 3 distributions of scatters around the line. Okay, so you can draw thousands distributions because scatters are there everywhere. We are considering this for the value at 15, the value at 20, the value at 25. That is, we are considering expected value of y given x is equal to 15, expected value of y given x is equal to 20, expected value of y given x is equal to 25. So we are considering these 3 levels only, okay? And we are finding that the spread of the scatter, that is variability of the observations around the fit, that remains constant as you move along the fit. This is the reverse of that. Just let me finish this diagram, then I am taking the question. Here, the same thing we have done. X is equal to 15, x is equal to 20, x is equal to 25. However, we are finding that the spread of the scatter around the fit, that is changing. This is not similar. Okay, the spread is changing. So this is the example of heteroscedasticity. This is an example of heteroscedasticity. The pattern is distribution of the error or distribution of the scatters around the fit that is changing. Okay, this is another example. It is the 3-dimensional plot. Here, this is the line, this is the XY plane. So this is the line and scatters are there around the fit. Again, we are considering the distribution at x1, x2, and x3. That is, we are considering expected value of y given this value of x, this value of x, and this value of x. And we are getting the spread as similar. So if I consider this vertical length of the distribution, if for these distributions, we are finding that these lengths are same. Whereas if you look at this diagram, this 3-dimensional plot, we are finding that, the wage, which is determined by education, that spread is changing as we are moving along the line. As we are moving along the line, the spread is changing. So this is the presentation of heteroscedasticity. So this one and this one are example of heteroscedasticity. Spread of the error around the central line or around the fit beta naught plus beta 1 x, that is this spread is changing. Whereas in this diagram and in this diagram, the spread is not changing. So variance is not changing. So these two are examples of homoscedasticity. So let me stop here today with the second assumption, and I'll take some questions. If you have any question, just you can ask me.
Ma'am,
Yes, Abhishek, I think you have, yeah.
ma'am, এই যে রিগ্রেশন লাইনটা এটা প্রত্যেকটা ভ্যালু অফ x এর জন্য এক্সপেকটেশন অফ y given x হয় তাই তো?
Yeah. Over time, all these things I'll discuss. So today, just I'm introducing the things. Today, I'm focusing on the assumptions, and idea of regression, etc. I'll tell you this fitted line is basically the mean value of y, expected value of y for given values of x. Okay, so today I don't want to discuss that point because that it will take 10-15 minutes. So one by one, we will discuss all these things. What is the meaning of this fit? Everything we will discuss. Today, you try to cover up to this. Regression equation is given by y is equal to alpha plus beta x plus error. Okay. And start studying the nature of the error term. Okay. Then I'll elaborate more on the fitted line, what does it mean, etc. Okay, so we will explain. I'll explain everything. Today, I'm not explaining because first I'll talk about assumptions, then I'll again come back to the fit and try to tell you something about the fit, and then only I'll move towards estimation. Any other question?
Ma'am, can you please take my attendance?
Yeah.
Yes, ma'am. আমারও আমি অ্যাটেন্ডেন্স দিতে পারি।
Regarding these lessons,
No, ma'am.
বলো কে বলছো?
ম্যাম রোল নাম্বার
Ma'am,
5